actual part 2, polar to rectangular coordinates. Now, take a look here. I'm going to give you a point in two-dimensional space. Let's say 2, 3. Where can I find 2, 3? 2, 3 is located 1, 2 on the x and 1, 2, 3 on the y. There you go. Here's our point 2, 3. Okay? There it is. But now I want you to get it from rectangular. I want you to make this into a polar. Okay? So we're gonna bring this over here, 2, 3 is right here in rectangular. I want to send it to become a polar. Okay? The way we transform it into polar is we utilize the transformation equations, which I highlighted in the previous video. It's that r is equal to the square root of x squared plus y squared. It's that x is equal to r cosine of theta, and that y is equal to r sine of theta. These three equations allow us to take 2, 3 and make it into something in terms of r and theta, a mathematical expression. So notice, we know x, this is 2, and we know y, this is 3. So I know x and y, and so that means I can directly calculate what r is. R is the square root of x squared, which is 2 squared, plus y squared, which is 3 squared. So then this equals to the square root of 4 plus 9. 4 plus 9 is 13, so this just becomes root 13, and this is what my r is, root 13. I'm in polar land. I know my r now. Now I just need to know my theta, and I'm done. Okay? Well, I know x, and I know y, and I know r now. I can solve for theta by taking the ratio of y over x, because I want to establish the tangent. Y over x would allow me to have a sine over cosine. So y over x, which is given by a rectangular 3 over 2, is equivalent to r, which our r is now root 13. Root 13 sine of theta divided by root 13 cosine of theta. Okay? But the root 13's cancel. So now I get 3 over 2 is equal to the tangent of theta. Okay? Now, in order to find theta, all I got to do is do the tangent inverse of both sides. So theta is equal to tangent inverse of 3 over 2. And whenever we plug that into our calculator, we will be able to determine what the tangent inverse of 3 over 2 is. Looking it up right now. Arctangent is also what it's called. Tangent of 3 over 2. What is it in degrees? In radians, it's 0.98 radians. But we'll figure out what it is in degrees. Over here, 0. So we see it's as 0.98 radians. 0.98 radians. So now we know theta, and now we know r in polar coordinates, which is r theta, versus rectangular coordinates, which is just x, y. I know my r is root 13. And my theta is this 0.98. So this is equivalent to that 2, 3. They are somehow describing the same point. It is not an equation because root 13 is not equal to 2. You know, we can't set them equal to each other component-wise. But we have now established a bridge between polar and rectangular. So now that we've done that, let's do one more example. Let's do another example in which the explicit value is able to be found. So instead of this point right here, let's pick the point 1, 1. All right, so that's this point here, 1, 1. I want to transform 1, 1 into polar coordinates because 1, 1 given to us right now is rectangular coordinates. The x value is 1, the y value is 1, and so we need to find what r is and what theta is. Okay? Transformation equations coming right up. R is equal to the square root of x squared plus y squared. X is equal to r cosine of theta. Y is equal to r sine of theta. Beautiful. So now our r is equal to the square root of 1 squared plus 1 squared, which is 1 plus 1, which is root 2. This is my r. Okay? Now, we take the ratio of y over x to get tangent. Y over x is really 1 over 1, which is equal to root 2 sine theta divided by root 2 cosine of theta. Remember, I'm just using this. I know r now is root 2. X is 1, y is 1. So y over x is 1 over 1, which ends up becoming 1. And this ends up becoming tangent of theta as the root 2's cancel. So now to solve for theta, I take the tangent inverse of both sides, which reduces to finding what the tangent inverse of 1 is. Now, whenever you plug it into your calculator, you get multiple values for the tangent inverse of 1. Because, technically, tangent inverse of 1 occurs at pi over 4 and at 5 pi over 4. Because on the unit circle, as you know, I'll draw it over here. On our unit circle, as you know, over here at pi over 4, we have root 2 over 2, comma, root 2 over 2 for the corresponding sine and cosine value. So since tangent is sine over cosine, root 2 over 2 divided by root 2 over 2 will equal 1. And that's why the tangent is 1 here. But there's another location at 5 pi over 4, directly across here, where the cosine and sine are negative root 2 over 2, negative root 2 over 2. Their ratio is also 1, because anything divided by itself is 1. So, which one do we pick? Do we pick 5 pi over 4 or pi over 4? Don't forget where 1, 1 is located at. 1, 1 is located in the first quadrant right here. Because it's located in the first quadrant, we pick the angle which is located in the first quadrant, which is pi over 4. Okay? If our point was negative 1, then we would have picked 5 pi over 4. But since we want to adhere to the location where 1, 1 is, we will pick pi over 4. So our r comma theta ends up becoming root 2 comma pi over 4. So now, given rectangular, you have learned how to convert into polar. In the next videos, we'll give you a polar and show you how to convert to rectangular.